Yes. Major 1 material is from class number 1 all the way up to class on Tuesday, next Tuesday. Week 7, Tuesday. One class before exam will be exempted. One class before exam will be exempted. Before that, everything will be covered. No, not chapter 1 and 2. I may finish chapter 3 before that. Okay. Week 6. Okay, let us start with the chapter 3 today. We had a brief introduction of chapter 3 in the previous class. We'll continue with that. In the previous class, we introduced a multiple linear regression model. In this regression model, how many unknown parameters are there? Mobiles in the pockets. Remind me to have the idea. I think I did not take the attendance. 3 minutes before the end of the class, remind me. How many? Yes. Recording is there. How many parameters are there in this equation? Not n plus 1, k plus 1. There are k plus 1 parameters, k slopes and 1 intercept, right? Principally, what should you do? You should do this. You have an objective function, which is summation of yi minus beta naught minus beta 1 x1i minus beta 2 x2i minus all the way up to minus beta k x ki whole square. This is summation epsilon I square. Principally, what you should do is you should differentiate it with respect to beta naught first, then differentiate it with respect to beta 1, then differentiate it with respect to beta 2, and all the way up to k. So you will have k plus 1 equations, k plus 1 unknowns. You will do what? Yeah. To minimize summation epsilon I square. This is the objective function. First B naught, then B1, then B2, then B3, with respect to each and every parameter unknown you have. So you will have to differentiate this thing k plus 1 times, each time with a different parameter, and you will have k plus 1 equations and k plus 1 unknowns. And from there, you will get the estimates for beta naught, beta 1, beta 2, all the way up to beta 1. This is an inefficient way of doing it. You plug it into the software, these equations, and it will give you a very long solution for this thing. The better way and the shorter way of doing this is to take this model, this same model, into matrix notation and estimate the parameters in matrix notation. That is much more easier. You can do that in one step. How do we do that? In the last class, we already defined the same model in the matrix notation. And we said this is the matrix notation of this model, this equation, and the one I wrote there, they are both same. These two are same things. There is no difference between these two. It's just that the notation of one is not in the matrix and the other one is in the matrix notation. They are exactly the same things. Also in the upper one, there are k plus 1 unknowns. Also here in the beta vector, there are k plus 1 betas, which are unknown. Right? So what we are going to do is we are going to estimate this model in the matrix notation, and we will try to get the estimator for beta. Which we will denote by beta hat vector. once you plug it back into the equation, your predicted equation will be y hat vector equals x beta hat. This will be your predicted equation. And you can write this predicted equation in beta hat. You will have again k plus 1 estimates. You can write it in either this form or you can write it back into this form. X is the vector containing all the sample information on X. Beta or beta hat? No, the beta. It contains all the betas. Here it is. It contains all the unknown parameters. Now the question is, what is our objective function to do that? Our objective function is the same. We have to minimize the sum of squares of errors. We'll do the same. That is, we'll minimize this quantity. But the question is, how do you denote this quantity in matrices? The answer is this same quantity in matrices can be written as epsilon prime epsilon. To show this, here is epsilon prime. Epsilon prime is here, epsilon 1, epsilon 2, all the way up to epsilon n. This is the transpose of epsilon true. And epsilon itself, we define it like this, a vector of all the epsilons, correct? If you multiply epsilon prime with epsilon, what do you get? You get epsilon 1 square plus epsilon 2 square plus all the way up to, which is basically summation epsilon I square. So epsilon prime epsilon is the same thing as epsilon summation epsilon I square. This is basically also SSE. The result, it will be 1 by 1. Epsilon prime epsilon will be a 1 by 1 because it's 1 by n into n by 1. So the result will be 1 by 1.
So what's the meaning of 1?
The transpose, sorry. Wherever you see me putting a prime, it's a short notation for the transpose. Everywhere. For the first one, it's a square, not a prime. This one is a square. This one?
No, I mean the prime is the.
Yeah, the transpose. The transpose of the column is a row. Now, what is epsilon from the model? The model is y equals x beta plus epsilon. What is epsilon? It's y minus x beta, correct? You just take x beta to the other side, you'll get epsilon. So let me multiply epsilon prime with epsilon. I will have y minus x beta prime times y minus x beta, correct? Epsilon prime multiplied by epsilon. True? So follow the direction. Yes, you have to be careful about the direction of multiplication. In matrices, A into B is not equal to B into A, so you need to be careful.
Speed is the same as B naught.
Similar, in the similar spirit, yes. It's the similar spirit, but this time you have more betas and more x's, more than one x's. So let's apply the transpose. When you apply the transpose on the first bracket, it will be y transpose minus x beta transpose. True? A minus B whole transpose is A transpose minus B transpose. Clear? Now, what is A into B whole transpose? A B whole transpose is B transpose into A transpose. So when I apply the transpose on X beta, it will change the order. It will be B transpose into X transpose. Clear? Now I'll multiply. It's a 2 by 2, so I'll just multiply the 2 with 2. So when I multiply the first term, it will be y prime y. Then I multiply the second term, it will be beta prime x prime y. Then the third term will be y prime x beta, and the last term will be beta prime x beta. 2 cross 2 will be 4 terms. Clear? Now be very, very, very careful about the order of the multiplication. Again, A into B is not B into A in matrices. Now, tell me, if I take this third term, y prime into x beta, I just took the third term, okay? And I take the transpose of this third term, what do I get? Again, the order will reverse. A into B transpose will be B transpose into A transpose. So I'll start from the right side. It'll be beta transpose, X transpose, Y. Is it the second term? Is it the second term? Which means that the second and third term, they are the transpose of each other. True? That is, second and third terms are transpose of each other. Correct? So I'm going to write it as a transpose y prime y minus beta prime x prime y minus beta prime x prime y transpose plus beta prime x beta. Any problems? No problems. Now tell me, yes. Again,
Term.
instead of this thing, I wrote this thing. It's the same. If you apply the transpose on this one, it will be y transpose x into beta, the same thing, right? I think I proved the other way. On that box, I proved the other way, is it?
Yes.
Yeah, I should have proved the other way. Both ways true. A transpose into transpose is again A. So it's what? Beta prime x prime y. This will give me y prime x beta. Now, try to anticipate the order of this thing, the second term or the third term. You can guess the order from many factors. What will be the order of this thing? This thing. If you want to guess the order, there are many ways to guess it. The first way to guess is you are adding these 4 terms, correct? The addition is only possible when the order is exactly the same. True? Which means the order of this one, the order of this one, the order of this one, and the order of this one, all 4 should be same. Otherwise, the addition is not possible in matrices. This is number 1. If you want to guess the order of this one, you can guess what. If you guess the order of this one, it will be same as this one. So what is the order of y prime y? It's a 1 by 1. Or what's the left side? The order will also be same for the left side. So what is the order of this one? 1 by 1, 1 by 1, 1 by 1, 1 by 1, 1 by 1. All 5 of them are 1 by 1. They are all 1 by 1 scalar quantities. You want to check it? Check it. What is the order of beta? It's k plus 1 by 1, right? So beta prime will be 1 by k plus 1. What happens? It came back. So let us try to guess. Beta prime will be 1 by k plus 1. This is beta prime. What is the order of x? X is k plus 1 by n. What is the order of y? N by 1. This is the second term. So what will be the final order of the answer? 1 by 1. Now what is the transpose of a 1 by 1? What is the transpose of a 1 by 1? The same thing. The transpose doesn't apply if it is a scalar quantity, correct? If it's just a 1 by 1, the transpose will be the same thing. So if I put the transpose on this thing or I don't put the transpose on this thing, it's the same thing. Clear? Now the second and the third thing, they are same. So it will be 2 times. It will be 2 times beta prime x prime y. Now this is the final expression that we are going to differentiate. Now I'll differentiate this whole thing with respect to beta. What is the derivative of this thing with respect to beta? Is there beta in there? Nowhere. The derivative will be 0. What is the derivative of this thing with respect to beta? What is the derivative of this thing with respect to beta?
The y does not contain a transpose.
It does not contain a transpose.
الباقي constant. حاول ندرب
Yes.
When you differentiate respect to beta or beta prime, it's the same. Because the one you have beta prime.
I know. That's why I gave you as an assignment to go and study. What is the day on 9th? 9th of October. Sunday. In the course? Total in the course? You never know. You never know. So let us put it equal to 0 and you have what? Minus 2x prime y plus 2 times x prime x beta equals 0. And I take this thing to the right side and I will have 2 times x prime x beta equals 2 times x prime y. 2 cancels out. Clear? And beta will be what? X prime y times x prime x whole inverse. Correct? I just took this thing.
Can't we cancel?
No, we can't.
Come to left from the left to the left.
Oh, no, we can. We can cancel, but the objective is to keep only beta on the left side. Then what will you do with x? We need to move the whole thing to the right side, just to keep beta on the left side. And when I did that, who objected? Nobody objected?
I think it comes to
Yes.
X.
Yes. Who else objects? Who knows what he said?
I think the order of the multiplication now, what's it? Is it correct that way?
Which way should be correct?
The other way, it should be
Which
x,
way?
x transpose. Or negative 1 multiplied.
What is the meaning of pre-multiplication and post-multiplication? It's different in matrices. It's not different in scalar, but it is different in matrices. As I said, A multiplied by B is not B multiplied by A. So if you have, let me go step by step, and what I wrote is wrong. You had this, you had x prime x beta equals x prime y, right? If you want to cancel this x prime x, you need to multiply with its inverse. Now what I did is I multiplied by the inverse here. It will not cancel. It will not cancel because there is a beta in between. You have to pre-multiply to cancel it. You have to multiply it from the left side to cancel it. So what you have to do like this. And finally, you will have the formula of beta hat. By the way, when I put it equal to 0, I should have said beta hat. And finally, your beta hat is which beginning?
How we differentiate with the transport? The first time I see it.
Go and check it. Go and check it. These two, how we differentiated this one with respect to beta and got x prime y. Go and check how this one happened. How I got 2 times x prime x beta. Go and check how this happened. This is like the derivative of a square. What is the derivative of x square? Or let's say a function of x whole square. It's 2 times the function multiplied by the derivative of the function, right? So in matrices, this is kind of x beta square. In matrices notation, you see summation epsilon square was what? It's epsilon prime epsilon. This thing is a kind of a square. Same x beta transpose and then x beta. This is kind of square of x beta, right? So if you take the derivative of some function of x whole square, it will be what? 2 will come down. Then it will be x beta to the power 1. And then another derivative of x beta with respect to beta will be x. So there will be 2 x's there. So that's what happened here. I want you to go and check the details of these two things. Go back to the matrices and check the details of these two things. You will find them. Yes. No. You will not find them. You will not find this. This doesn't belong to the regression course. This doesn't belong to 310. This is the knowledge you should have before 310. Now, my question is, what will be the final order of beta hat? It should be the same as beta because this is estimating what? Let's confirm. What is the order of x? N by k plus 1. What is the order of x prime? K plus 1 by n. Then you have whole inverse. Then what is the order of x prime? Sorry, n by k plus 1. N by k plus 1. What is the order of y? N by 1, right? Now, when you multiply these two, the order of x transpose x will be k plus 1 by a symmetric matrix, k plus 1 by k plus 1. You take the inverse of a symmetric matrix. What do you get? Same, k plus 1 by k plus 1. Then you multiply it. Can you multiply it?
You flip the x.
This one?
No, in the bracket, the other bracket.
In the bracket?
Yes.
X.
Should be n multiplied by k plus 1, right? The x transpose.
X transpose, how many rows? No, it's correct now. Now it's correct. So the final answer of this one will be k plus 1 by n. Sorry, by 1. So it will be something like this. It will be something like this. It will be beta naught hat. The first value of this column will be beta naught hat, then beta 1 hat, then beta 2 hat, all the way up to beta k hat. Now it's your choice. You want to write it in terms of matrices, or you want to take these numbers and write it as an equation. You can simply write it as an equation. Let us quickly find this and see how this works. Very easy in Excel. You just have to do a couple of steps and you will get the beta. For this, I'm going to use the data set. For example, 3.1. And I think for next 6 to 7 chapters, we'll be using this example. 3.1, delivery time. Where is copy? Okay, here is the data. This is the same data, delivery time, number of cases. And this time they brought another variable that is affecting the delivery time. By the way, this is the same example of filling the vending machines. How much time do you need to fill the vending machine? So the time for filling the vending machine, they said initially in chapter 2, they said it is dependent upon the number of cases you have to fill into the vending machine. Now they are also saying that it also depends upon how much distance the person has to travel to get to the vending machine, because that time is also included in the time. So the number of cases, how was it related to the time of the delivery? If there are more cases, you will need more time, and the distance will also be positively related. Both of them should be positively, is it? I don't know what is the distance they are. We will see. Anyhow, we will see. So the first thing we need to do is we need to go back to week 5 and we need to see how do we define our matrices. The first thing you need to do is you need to write down your data in matrices. Now this, take a picture of this one and keep it with you. This is how you need to define Y and X. That's it. Y and X is your data. This is how you need to define it. Y as a column, X as a matrix, but you should have an extra column of ones before the X's, which we don't have at the moment. So what I'm going to do is, first column, I have this one. I'll denote it by Y. I don't have a problem. But before X's, I need an extra column of ones. So I'll create here an extra column and put all the ones here. Now I need to define the matrices like we define the names. I will select this column and define the name from the formula name manager, define the name. From define name, define the name of this one as Y. Again, you can do this without defining the name also. Defining the name will make it easier for you to follow the things in the future. And this whole thing, this will be my X matrix. So I define the name of this thing as, let us say, XM, X matrix. Now in one go, I will have beta hat, and which go I'll directly go to the formula of beta hat. Where is the formula of beta hat? Look here, I'll use this formula. In one go, I will write all the things. What do I need to do? I need to first multiply the bracket X transpose with X, then I have to take the inverse of this. Then I have to multiply it with X transpose. Then I have to multiply it with Y. Now the problem with Excel is Excel will not multiply the 3 matrices at the same time. You have to use the multiplication command 2 times. If you want to multiply A into B into C, first multiply A and B, put a bracket over it, and then multiply the product with the C with another multiplication command. So here I have 3 or 4 things, I'll use multiple multiplication commands in Excel. So let me start with X transpose X. You don't need to find it separately, but I will show you how this X transpose X looks like. In the end, I will do all of it in one command. Now tell me, what will be the order of X transpose X? X transpose X, K plus 1 by K plus 1. K is 2. K plus 1 is 3. So the order will be 3 by 3. I will select a 3 by 3 space. Let's say here. And I'll write equals. Matrix multiplication command is MMULT. What is the first thing? X transpose. So again, I'll write the transpose of what? XM. And multiply it with what? XM. Control, Shift, Enter. To multiply the matrices, you don't need to press Enter separately. Control, Shift, Enter. This is X transpose X, 3 by 3. I take the inverse of this thing. Again, select a 3 by 3 and write M inverse of this thing. Control, Shift, Enter. Here is the inverse of that matrix. What's the next thing in the formula? X transpose Y. X transpose Y. What will be the order? The order I'll tell you will be 3 by 1. So I select a 3 by 1 and write equals matrix multiplication transpose of X with Y. Here is X transpose Y. And final step, I'll multiply the X transpose X whole inverse with this whole thing with this whole thing. And I'll get this. The first number is beta naught hat, the second number is beta 1 hat, and the third number is beta 2 hat. There are 6 minutes left. Now, as I said, you don't need to go step by step. You can do all of this in one step. How? Look. And also you don't need to give the names. If you want to go one step without giving the names, here you go. The first thing is you need to anticipate the final order of the answer. What is the final order of beta hat? 3 by 1. Select 3 by 1. Go from the innermost bracket. What is in the innermost? There is X prime X. So write transpose of X. Now I'm selecting, assuming I did not give them the names, but see, when I select it, it will automatically make it X. This is all X. Transpose of this with this, and outside I'll put the matrix multiplication command. This is what? X transpose X. I need the inverse of this one. So again, outside this one, I'll put matrix inverse. Outside this, I'll put matrix inverse. What is this? This is the X transpose X whole inverse. I need to multiply it with Y, with X prime first. So I'll put comma and write transpose of this X and put the multiplication outside. Now this is X transpose X whole inverse X transpose. Last thing, what's left? Again, multiply the whole thing with Y, comma, here is the Y. Now here in this one command, I did not assume I gave the name. I did not assume anything. I had the data and I did everything in one go. The same answer we get. Matrix multiplication.
You're okay with both of them, so we can do.
Anyway. So once you have this beta hat vector, be clear that the first quantity is the intercept. 2.34 is the intercept. 1.61 is the slope against X1. 0.014 is the slope against X2. So now it's up to you. You want to write the model in terms of matrix, or you want to write the model in terms of an equation, you can write it. You will write an equation to y equals 2.34 plus 1.615 times x1 plus 0.014385 times x2. This is your fitted model. If for a future you want to do the prediction, you will have the value of x1 and x2, plug it in and do the prediction. Yes.
So always the K down.
Again.
The K for beta will be down.
Yeah. Look at the screen for your full name. I'm going to take the attendance. Ahmed. Bender. Ahmad Mustafa. Ahmad Ahmed. Hussein. Saud. Abdullah.
Yes.
Saud Abdulaziz. Salman.
Yes.
Hamad Ahmed. Salman Abdullah.
Yes.
Faisal Fahad.
Yes.
Hamad Abdullah. Fahad Khalid. Abdurrahman.
Yes.
Hamad Suleiman.
Yes.
Hamad Ahmed.
Yes.
Hamid.
Yes.
Haytham. Adib.
Yes.
Ibrahim.
Yes.
Yusuf.
Yes.
Hussein.
Yes.
Hassan.
Yes.
Abdul Hadi.
Yes.
Ahmed.
Yes.
Jawad. Ahmed.
Yes.
Abdulaziz. Ahmed.
Yes.
Mishal. Saad. Fahad. Fahad.
Yes.
Abdulaziz.
Yes.
If you have any question from today's class, you can ask. Otherwise, you can leave and what? Nothing. 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 Enjoy yourself.
Let's find the formula. That's fine. You said.
The formula? Here it is. You click on this F of X. This will give you all the functions here.
Can I define my own functions?
Your own formula? There are ways to define your formulas through macros, but we'll not discuss in there. But if you're interested, go search how to define a formula through macros. There are Excel macros. Macros you can do it through macros.
They would love to use it.
Yes, why not?
Can I submit the homework today? Is that okay?
No. Once it is done, come to me. Tomorrow before the class, come to me.
Okay, if I do that.
How many free absences? There's nothing free in this world. How many do you have?
So.
Two. Keep it less than 3 in the semester. It's okay. 3 or less than 3. For yes, there is, but for 3 and less, I will not deduct. So to answer is short, 3 free absences.
So absence and 1 late.
3. No, late is not a problem.
Now, it will be on Saturday and on Thursday I'll be in Rio. Should I come
What time do you have on Saturday?
on 2 p.m.?
Yeah, once you get free, come here directly.
So
Even if late, no problem. I'll start late. Okay. So by what time you will be free from there?
maybe if you want me to come, I'll come on Friday.
No, not one day before. Saturday you can come, but it's okay to be late. The exam will start at 6. You can come 7, 7:30 anytime you get inside. You just come to the exam. Okay. Don't worry about it. Yes.
Regarding B0 and B1, are they able